In this video, we're going to demonstrate the relationship between bond prices and yield to maturity. We are going to do that in an Excel framework. As a reminder, our bond price equals our discounted cash flows, where our discount rate equals the yield to maturity. Our yield to maturity is the yield or discount rate that causes our discounted to cash flows to equal our bond price. If we know the bond price, we can find the yield to maturity. If we know the yield to maturity, we can find the bond price. So we're going to demonstrate that. We're going to do that with this following case. We're going to take a 4-year note, given where we're working with treasuries. As always, we have 8 semi-annual periods, or 8 semi-annual payments. Our coupon payment, or our coupon rate in this case, is going to be 2% of $1,000 par. Again, our periods are 6-month periods, and we're going to divide the coupon rate and yield to maturity by 2% to put it on a 6-month period. Okay? That's what we're going to do. Here is our setup. We have our 4-year maturity T-note. 8 periods here. They are 6 months long, so this is 6 months, a year, 1 year and 6 months, 2 years, 3 years, 4 years. Our cash flow is $1,000. Let me just make that wider a little bit. Nope. We can see the formula. 1,000, 2% coupon rate divided by 2, come up with 10. In our last period, we get our par back as well. Discount. We're going to start with a yield maturity of 1.5%. We know that. If we know the yield to maturity, we can find the bond price. That on a semi-annual period is just divided by 2. 0.75%. All right, we take our discount factor, 1 divided by 1 plus the discount factor raised to the period. First one is raised to the 1. Last one is raised to the 8th. Comes up with our discount factor. We then multiply that by our discounted cash flow. So our $1,010 cash flow in the future, our discount factor is 0.9419. Multiply the 2. There's our discounted cash flow, that 1010. It's 951. Sum it all together. And given these cash flows and this yield to maturity, our bond price is $10.1934. All right, we know that. Now let's do the opposite. We're going to put this again is our time period. All right. We have them from 0 to 8. Our first cash flow in 0 is minus 10.1934. And now I'm just going to put the rest of them right here. All right. Now, if we want to find the yield to maturity, we would use the internal rate of return. I'm going to put it right here. And remember, IRR finds, put them all in there, and it's going to find the discount factor that causes those flows from 1 to 8 to equal minus 10.1934. So it all equals 0. It's 1%, which actually is smaller than that. Let me make those. There it is. So let's now put it on a yearly basis, 1.5%. All right, that happens to be the same thing that we started with here. But now, if let's say we don't, we know the price and it's 10.20. we can use, if we know the price, we can, oops, 1020. We got to put a minus sign in there because otherwise it doesn't solve. If we paid 1020 for this, we would have a 1.483 yield to maturity. We paid 1030, that yield to maturity is going to go down 1.229. So as you can see, there is a relationship. Let me put that back to minus what it was. And now let's just demonstrate. Let's say this is yield to maturity. We're going to say is 0.02, or it's 2%, 1% semi-annually. That would mean our bond price is 1,000. And do the opposite. We come up with the yield to maturity, multiply it by 2. Here's our yield to maturity stated in an annual basis.